For people who are watching the video, this is a checkpoint that we're doing, and so you can read through the question, and we just kind of set up number 1, and we're answering these, not all, we're taking them step by step here. So can somebody tell me what you computed 1/3 integral from 0 to 3 of v of t dt is? Shall I compute myself? It is not confident. I've got 0.7735 divided by 3. I got 0.257. What's my label? Yep, meters per second. Nope, just meters per second. Understand what's being asked, okay? You're asking the average velocity. Velocity will be measured in meters per second. Distance will be measured in meters. Acceleration will be meters per second squared. Everybody got that?
They passed us on May 13th, right?
I don't know.
That sounds right.
Yep. All right, second question. What's the acceleration of the particle at 1 second? Okay, what is the acceleration of the particle at 1 second? Take 30 seconds and try to write down what would we use to determine the acceleration of the particle at 1 second. Okay, you should have the simple derivative of the velocity function at time is equal to 1. And if you even wanted to write b prime of 1 is equal to a of 1, okay, the acceleration of 1 second, that's fine. The point is that that's the work that they want to see on the AP exam. That's what I'm looking for on your test. You would take the derivative of velocity. As you did that, you should get 1.081. What is my label? Good. Okay, number 3, what is the average acceleration? Notice another question involving average, and it involves acceleration. What does that look like? It's from time equals 0 to time equals 2. See if you can write out the computation, and then I'll let you compute it on your own eventually here. 5, 4, 3, 2, 1. Acceleration means you take the derivative, but it's not instantaneous average. So therefore, you're looking for the slope. So it'd be v of 2 minus v of 0 divided by 2 minus 0. Who got that? Good job. See if you can now compute v of 2 minus v of 0 divided by 2 minus 0. Negative 0.378. My label obviously is meters per second squared. Okay, please write an expression that would give us the total distance traveled from time equals 0 to time equals 3. Total distance traveled from time equals 0 to time equals 3. So you can write that expression. We have 20 seconds here. I should see the integral from 0 to 3 of the absolute value of v of t dt. Absolute value. We got that? Good job. Total distance. Distance is always going to be the absolute value. So you can type, see if you can type that into your calculator and figure out that exact value. Couple ways to do it. I am going into my calculator and I'm setting up an absolute value function for y sub 2. I'm using my bars option. See if your calculation comes up the same as mine. Are we okay with that? Okay, your final one. Try to write an expression for the position of the particle at time is equal to 2. Position of the particle at time is equal to 2. Hint, if you're confused, position is the same as start plus displacement. Scroll up.
So we can see where we start.
Oh, sorry about that. So what you had? Displacement is just the integral. Okay, it's not the absolute value, it's just the integral. That's displacement. So now you can calculate that on your calculator. I've got negative 0.226 meters is its current location. You good? Okay, score that out of 5. There were 5 questions. How do you think you would have done had we not kind of given the help? Where are you at right now? Are you a 2 out of 5? Are you a 6 out of 5? Can't be 6 out of 5. But where are you at? Okay. I'll take that from you guys. Just 2 problems we want to look at today. Tomorrow we want to do a short kind of AP review, start exposing you to some of those problems. You're really in the thick of it, and we're through chapter 5. There's not much more we need to get through before you really finish the vast majority of the content. Today's lesson is pretty simple and straightforward. I think you guys are going to like it. And then you'll have time to work on Friday and on Monday. I will give you your study guide tomorrow. Is study guide tomorrow okay, or do you guys want me running copies today? Can we do tomorrow? Yeah. Okay. Okay, substitution rule for definite integrals. Notice that the substitution that we've been doing has involved indefinite integrals. Indefinite integrals are where there are no bounds. What if we have an integral that is bounded by a and b? And suppose we make a substitution. Suppose that our substitution is going to be the variable u. It then becomes du, and instead of an x, I have a u, don't I? Okay. That's my new variable, u. And the bounds then change. Instead of a, it would be whatever you get when you plug a into u. And instead of b, it's whatever you get when you plug b into u. So it changes as such. So we won't go through the complete evaluation of all these. And this isn't a huge deal, but it does come up a little bit. Every once in a while, I'll see one on a test. It can make things easier for you, which is kind of why I show it to you. And I do ask you to do this, on the test as well. So evaluate the following definite integrals, definite, not indefinite. They are bounded using the substitution rule. So we want to make sure we substitute for bounds. Let's start by determining an antiderivative. What would u be in this scenario for example 5? X squared plus 3, and what is du? 2x dx. I don't have a 2x dx, so what are you going to do? Good, so I have 1/2 du is equal to x dx. I have my substitution. My substitution is quite simple. I have a 1/2, I have an integral, and I have du. That allows me to get rid of the x and the dx. What remains? U to the 4th. Now for the bounds. The bounds are quite simple, okay? Instead of 0, I'm going to use 0 squared plus 3. What is 0 squared plus 3? So 3 is my lower bound. And then my upper bound, instead of using 2, I do 2 squared plus 3. What's 2 squared? 4 plus 3 is 7. So my bounds change to 3 and 7. Now watch what you can do. This is quite nice. What is the antiderivative of u to the 4th? U to the 5th over 5, so it will be u to the 5th over 10. Everybody agreed? And I do not need to plug x back in. I can simply just evaluate it at 7 and 3. If you were to use, if you were to plug this x back in, this x squared plus 3, if you were to plug that back in for u, then these bounds would change back to 2 and 0. You know what I'm saying? You use these bounds if you're working with x. You use these bounds if you're working with u. Everybody see that? So as I evaluate this, I just have 7 to the 5th over 3, or over 10, excuse me. And I would subtract from that 3 to the 5th over 10. And whatever you come out with, that would be your answer. That's that. Not too bad? So just understand the change of the bounds. Our last one, what do you choose u to be in this scenario? Good. U is sine of x. So du is cosine of x dx. Excellent. I have my substitution. We made it very, very simple. My simple substitution is just du. I don't have any multiplier. And what remains? U to the 3rd. So now let's change, yes, sir. Let's then change our bounds. Our bounds, I don't use 0 and pi over 2. Rather, I do the sine of 0. What is the sine of 0? 0, very good. And then we do the sine of pi over 2. Aiden, what is the sine of pi over 2? 1. Okay. When the teacher calls on you directly, usually it's because you said the right answer before.
I'll have to remember that.
Yeah, that's all right. That's all right. That's all right. Thank you for your honesty and your interest and your answers. So now I don't have to deal with pi over 2 and the 0. I get to do the 0 and 1. The antiderivative u to the third is u to the fourth over 4. I'm going to evaluate that at 1 and 0, which is obviously just 1/4. I mean, when you look at the problem right away, it doesn't look like it'd be really challenging. And in fact, it's not. It's very straightforward, okay? That's going to allow you to finish up the rest of your work, okay? And so as you look at the substitution rules, the next one is the integration of bounds, okay? So you're practicing substitution by putting in, changing the bounds. And that's really the last thing that you're going to do. You're going to have a day to work on Friday, a day to work on Monday. I'll give you the study guide tomorrow. Tomorrow we're going to do an AP practice piece. You have about 10 minutes right now. You could ask me questions and knock them if you want to. Does anybody want to say hi to anybody who's watching the video right now?
Hi, Taylor, Zizi, and Aaron, and Jordan. Addie.
Hi, Matthew.
Oh, okay. Thank you. Aiden, give a shout out to Matthew. We got a lot of people. Well, Lily is naming a lot of people there. I didn't hear you say
Yeah,
JoJo.
we didn't do any of them.
Did we do Emma too?
Oh, yeah.
No, you guys forgot about Emma.
Hi, Hannah.
We got Hannah.
And
Aiden is in the great state of
JoJo.
Arizona.
What?
Aiden, we want you to know that we will be, I already set up a high jump pit.
Who was playing basketball?
Are we going to, should we put, since there's multiple, should we put a hidden word inside the video? Or hidden phrase?
Supercalifragilisticexpialidocious.
I was thinking
for
Kayla.
Kayla, after the-
I don't know if I want
I don't
that
know.
as the phrase. Let's do something that's a little bit more Christine or mathematical.
The
Fine.
dress up day tomorrow.
What is the dress up day tomorrow?
Is it
You have
the,
dress up days right now?
It's FFA week.
yeah.
USA Day, maybe?
It's
Yeah.
FFA,
No, we already
so
did
it's
USA.
USA Day tomorrow for the dress up.
Maybe.
So how about something that is America related?
Okay.
Remember the Alamo. That is the phrase. If you send to me, remember the Alamo first, then you get to choose a treat from my stack of treats. Remember the Alamo. Send me a message over email or come and tell us me in my face. If you want to phone call me, you can call me at 507-379-5455. There you go. Remember the Alamo.